Exponential function is a function that has a base and exponent. That means it's two parts, b to the power e, where b is a base and e is exponent. When will this function be equal to 1?
C equals 0.
When?
If C equals 0.
Oh, e, this is an e. E for exponential. Okay. So when e equal to 0. Good. So when e equal to 0. Let's suppose that I took the base 2 and over here I put x. Is this an exponential function?
Yes.
Okay. If I put x and I put this, is this exponential function?
No.
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 Good. So why? Because this grows exponentially, right? It grows exponentially. Now, I'm going to put over here 3 to the power x. Okay? So this is 2 to the power x, 3 to the power x, and I'm going to put e to the power x. E. E is between 3 and 4, between 3 and 2. Okay? So this is something like this, where e is 2.7 something. You know what e is, right?
Yeah. 2.717, I think.
Yes. So e is greater than 2, but less than 3. So if I have to plot 2 to the power x, okay? If I have to plot to the power x, where x is the x-axis. So I'm just going to go ahead and draw something like the x-axis. And let's say this is the y-axis. This is the x-axis. Okay? So this is x equal to -1, for example, -2, -3, -4, and it keeps going. It will go until -infinity, but it will never reach -infinity. Over here is +1, +2, +3, +4, all the way until it gets to infinity. But it will never reach it. Okay, if I'm moving this way, the function 2 to the power x or e to the power x or 3 to the power x, is it going to be increasing or decreasing?
Increasing. Increasing.
Increasing. Okay, if I put 2 to the power -1, that's going to be equal to what? 1/2, right? Right? If I put
Yes.
2 to the -2, that's going to give me what? 1/2.
1/2. 1/4.
1/4, yeah.
1/4, right? So is it increasing or decreasing? 2 to the power -1,
Decreasing.
to the power -2, 2 to the power -3 is equal to what? 1/8, right? So it's decreasing, right?
Yes.
Decreasing if I move to the left, right? What about if I move to the right? Decreasing or increasing?
Increasing.
2 to the power 1, 2 to the power 2, 2 to the power 3. So this is 2, this is 4, this is 8. So it's increasing, right? Now, at 0, what will the value be? 2 to the power 0 will give me what?
1.
1. So it has a value of 1 here, but then it will continue to do what? Continue to decrease, right? Decrease, and will continue to decrease going towards infinity, but it will never touch the x-axis, right? And over here, it will continue to increase, right? Yes?
Yes.
Okay. So having said so, let's go ahead and take a look at the graphs of these three 2 to the power x, e to the power x, and 3 to the power x. Okay, this is the graph of y equal to the power x. See, it's stretching. By stretching, I mean it's moving and taking more and more of the x values. But 10 to the power x, you can see it's not covering much of the x before it goes to infinity. So this will reach infinity faster, right? The y value will reach infinity faster before what? Before the x value, right? But over here, for 2 to the power x, the x will reach infinity faster than y, right? The x value will reach infinity faster than the y value, right? Do you understand what I'm saying?
Yes, doctor.
Okay, so this we will call stretching. stretching يعني يتمطى يعني يتمدد. فهذا بيتمدد على ايش؟ على الاكس اكسيس. stretching. And this is compressing. This is compressing. compressing يعني كل ما عليه ضاغط جاي ماشي لهيك. Okay? But this is not really that important. It's just that you might find it maybe in this book or maybe in somewhere, but this is what it is, okay? Now, what if we put negative exponent? We get these graphs. So this is y equal to 2 to negative x, and this is y equal to 3 to negative x, and this is y equal to 10 to negative x. Okay? So you can see that it will decrease. It will continue decreasing until it moves to 1, then continue to decrease that way. Okay? So the functions over here increasing that way, over here decreasing, right? Because of the exponent. Is that clear?
Yeah.
Okay. Now what we will do now, we will take a look at the value of 2 raised to the power square root of 3. 2 raised to the power square root of 3. Square root of 3 is equal to 1.732 something. This is equal to square root of 3. Okay? So assume that we're taking the exponent as r. We're going to start from 1, and we're going to use 2 as the base. So this is the base 2, and this is the exponent. So we're going to have the value of the exponent from here. So we will say 2 raised to the power 1 will give us this, right? 2 raised to the power 1.7 will give us this. And if we keep increasing over here until we get what? Closer to square root of 3. This is square root of 3. If you do the square root of 3, you will get 1.732 something. Okay? So look at the right-hand side. The right-hand side is the function. This is the value at the x-axis if you wish. Okay, and these are the values at the y. So the y value of that is going to converge, and it's going to come to 3.321 something. Okay, so the conclusion is as follows. Values of 2 to the power square root of 3 for rational are closer and closer to square root of 3. That means you start with r1 and you keep going closer and closer to the square root of 3. That means keep going closer to 1.7232 this. Okay? So if that is the case, then 2 to the power r is going to be behaving that way. Okay? And you can use this one to plot the function, of course. We will do something similar when we be looking at the limits, but not today. Okay. Let's get to the next.
Okay.
Over here, this is 2 to the power x, and this is e to the power x, and this is 3 to the power x. Okay. Now we look at what? We look at their slopes. The slope at 1 of 2 to the power x, the slope is equal to 0.7. For the curve, the blue curve, which is e to the power x, the slope at 1 is equal to 1. For y equal to 3 to the power x, which is yellow, okay, the slope is 1.1. You can see the slope is increasing as we increase what? The exponent or the base. Over here, we're increasing the exponent or the base?
The base.
The base. As we increase the base was 2 here, the slope is 0.7. The base is e, the slope is equal to 1. Over here, the base is 3, the slope is equal to 1.1. Why do you think the slope over here is equal to 1? Because this point over here, this point is equal to 1, right?
Yes.
Okay, and this point will be equal to 1. So if this point is 1, if this point is 0, 1, then this point will be what?
1,0.
1,0.
-1 and 0.
Minus 1, 0. Good. So that means the slope will be this divided by this. So 1 divided by 1 will give you 1. Okay? Okay, Shabab?
Okay, okay.
So the conclusion here is, among the exponential functions, the graph of y equal to e to the x has the property that the slope m of the tangent line to the graph exactly 1 when crosses the y-axis. Okay, the slope is smaller or a base less than e. Okay, such as 2 to the power x. The slope is smaller, 0.7, less than 1, and larger than 1 for a base that's e, such that 3 to the power x. 3 to the power x, it's larger than, right? Larger than e. واضح يا شباب؟
واضح.
Now, here is an exponential function, but this time we are multiplying a constant times the exponent, which is x. So y is equal to e to the power 1.5x, and over here y equal to e to the power negative 1.2x. So since this is positive, then as we increase the value of x, the function will be what? Will be increasing, right? But over here, as we increase the value of x, the function will be what? Decreasing, because it's negative exponent. Very good. Okay. So graph A, exponential growth, k equal to 1.5 greater than 0. And exponentially decay, that means losing value from y. Decay, losing value from y. Why? Because k is equal to negative 1.2, which is less than 0. Okay, just the behavior of the exponential functions. I mean, this is just an introduction to the behavior. Okay. Okay, inverse functions and logarithmics. Okay, I didn't go through this one with the rest of the class, but anyway, I will go through it with you. Inverse of the function. We look at this function, we see y equal to x cubed. And this function y equal to square root of x, right? Y equals square root of x. That's a curve. And this is the curve of y equal to x squared. Let me ask you this question. What does it mean to say a function is one-to-one? Okay, let me just do this. If you've been looking at the videos I told you, you would have answered the question.
Yes, I know, doctor.
So this is
Can I
the
answer?
domain. Good. This is the
No,
range.
it's not yet.
Huh? This is the domain, this is the range. So let's say I have the points 1, 2, 3, 4. Okay, and I have the points A, B, C, D. Okay, I'm going to do this. I'm going to do the mapping. Is this a function?
Yes, doctor.
Yes.
It is a function. Correct. Is it one-to-one?
Yes.
No.
No,
It's not one-to-one. Why?
because one-to-one, it should every number has different number in range.
Right. So here, the violation is where at 2 and 3. The 2 and 3 in the domain are mapped to B, right? 2 and 3 are mapped to B, right? That means f of 2 is equal to B, right? And f of 3 is also equal to B. So it's not one-to-one. One-to-one, that means what? That means 3 is mapped
Every
to
X
C.
value of the
Okay, so this is one-to-one. Okay. Okay, Shabab, you understand what one-to-one means?
Okay.
yeah.
Yes.
Okay, let's suppose that this is your scores. Your scores, and over here, the grades. Could be A or B or C or D or God forbid F. Okay, the mapping will be what? Is it going to be one-to-one?
Yeah.
Yes.
Is it going to be one-to-one? That means only one student get an A, one student get an B, one student get C, one student get D, one student get F.
No, not function.
It is a function.
Function
A
one-to-one.
function, but not one-to-one.
Yes, a
No.
function, but not one-to-one. Unless you have just 5 students and one of them got A, the second got B, the third got C, and then the last got F, unless that's the case. Otherwise, mapping the scores to the letter grade is not one-to-one, usually. Got it? Okay, if I have 1, 2, 3, 4, and I have here A, B, and let's say C. Okay, and I have this mapped over here, and this mapped over here, and this mapped over here. Okay, is this a function?
No,
Yeah.
no,
It's not a function. Why?
because domain number in domain not mapping in range.
Excellent, excellent, excellent. For it to be a function, every member of the domain must be mapped to a unique member in the range. For those of you who did not go through the videos, please go through the videos. They have very valuable information for you. It's going to make the course easier for you later on.
Hector,
Yes.
can you explain the second one again? Why it is not one-to-one
Which
function?
one?
The second one.
This one?
Yes.
Okay. Now, how many letter grades do we have?
4,
A, B, C, D, and F, right?
5. Yes.
Okay. How many students in the class we have?
5.
No. If we have only 5 students and the first student got an A, the second student got B, the third student got C, and the fourth got D, and the fifth got F, yes, it's 1-to-1. But is that normal?
No, it is not normal.
So we're talking about what the normal is. So in general, for grades, maybe 1 or 2 students will get A's, maybe 5 or 6 students will get B, and C, maybe there are 10 students, and then this. So that's why we said the grades are usually not 1-to-1.
Yes, I understood.
Good, very good.
Doctor,
So everybody knows what 1-to-1 means. Yes, go ahead.
Doctor, I have a question.
Huh?
If there are a number in domain doesn't mapping in range is not function. I'm right?
Yeah,
Am
if
I
there's
right?
a number in
Okay.
domain and that's not mapped, it's not a function.
Therefore, Doctor, if there are a number in range not mapping with domain, no problem.
No problem, it's a function.
Okay.
Yeah, 1, 2, 3, 4, okay. And I have this 1, 2, 3, 4, and 5, okay. If I map 1-to-1, 2-to-2, 3-to-3, 4-to-4, and I did not map 5, it's still a function. It's still a function. Okay,
Okay, clear.
good. So 1-to-1, that means every element in the domain mapped to one element in the range. And every element in the range is mapped to by a single element in the domain. Then the function will be 1-to-1. Okay? Now let's take a look at the graph of this. The graph of this y equal to square root of x. Okay? Now, if y is equal to square root of x, is it 1-to-1? Huh?
What, Doctor?
Yes, doctor.
It is 1-to-1, right? Because
Yes.
no 2 different numbers will have the same square root. Right? Do you find
Yes.
2 numbers have the same, 2 different numbers have the same square root? No. So it's 1-to-1, right? Okay.
اوكي دكتور.
واضحة؟
ايوه واضح.
Okay. So that is 1-to-1. Okay, let me give you another function, y equal to x squared. Is it 1-to-1?
No, Doctor.
Okay. 1 minus 1, 2 minus 2. Okay, now the mapping. 1 maps to what? To 1. -1 maps to what? To 1, right? 2 maps to what? To 4. -2 maps what? To 4 also, right? Yes?
Yeah.
Yes.
Is it 1-to-1?
No, no.
No, it's not 1-to-1. Okay, so a 1-to-1 graph. Why? You can see y equal to x cubed. Okay, graph meets each horizontal line at most once. So the criteria is to draw a horizontal line. If the horizontal line crosses the function at one point only, the function is 1-to-1. شو القصد من هذا؟ القصد من هذا انه ننزل هذا تحت. The value of x here is unique. نزل هذا تحت. The value of x here unique. The value of x unique and keeps going. Okay? But look at the bottom here. The horizontal line crossing the function at what? At 2 points. So this is not 1-to-1. صح؟ معناه ايش؟ معناه عندك x equal to 1 have the same y value as x equal to -1. That means 1 and -1 have the same y value. This is 1 has a value of 1, -1 have a value of 1, which is representing this, right? 1 and -1. صح? 1 has a value of 1, -1 has a value of 1, so this function is not 1-to-1. Why? Because 1 maps to 1 and -1 maps to 1. Is that clear?
Clear.
Everybody?
Yes, Doctor.
Okay, and same thing in this function. So what is the criteria? The criteria is the horizontal line. Okay, if you have the horizontal line crossing the function more than 1 point, the function is not 1-to-1. If it is exactly 1 point, the function is 1-to-1. What about the vertical line? The vertical line will test what?
If it's a function or not.
Excellent, if it's a function or not. Okay, so if the curve is like this, it's a function, right?
Yes.
Okay, but what if the curve is like this? It's not a function, right? So the vertical
Yes.
line tests whether a graph is for a function or not, and the horizontal line tests whether the function is 1-to-1 or not. Is that clear?
Yes, Doctor.
Good. Okay.
Doctor,
Yes, yes.
I have a question about
Sure.
1-to-1. If
Uh-huh.
there are table,
Table.
okay,
Uh-huh.
and there are number in range doesn't mapping, no problem.
No, it cannot be 1-to-1 and a number of range not mapped. It's not 1-to-1.
Okay. Okay.
Good question.
It has every number mapping.
Good question. Look, here you have something like this and something like this. Let's suppose 1, 2, 3, 4. Okay. And then over here, A, B, C, D, and E. Okay. we have how many values? 4 values here. We have 5 values here. If we map A to 1, B to 2, C to 3, and 4 to E, okay? Is D mapped to anything?
No.
It's not, okay? So can we call this function 1-to-1?
Yes. No. I don't know.
Okay, let's listen to any other, okay. Anybody else? Is this function 1-to-1?
Yeah.
Huh?
No, it's
Yes.
not.
No.
One to one.
No.
I'm gonna leave it for you to think about it. And I'm gonna ask you about it next class. And one more time, please go ahead and review the videos I told you. You will find the answers there, okay? You will find many things that we don't discuss in the classroom. You'll find them there, okay? So let's just look at the summary over here, okay? Y equal to f of x is 1-to-1 if and only if its graph intersects each horizontal line at most once. Okay, now here is a table. Okay, this table shows the x values on the top first row and the y values where y is equal to f of x on the bottom. Okay, which are these values? Now, suppose a 1-to-1 function y equal to f of x is given by this table. Okay, so these are the values of x and these are the values of y. Okay, look in the bottom here. We changed what? We changed the values of x to be the values of y and the values of y to be the values of x. Okay, so when we do so, we are finding the inverse of the function. واضح يا شباب؟ If we change the y values to be the x values and the x values to be the y values, then we're talking about what? A function that has an inverse. Okay?
Okay.
Now, let me ask you this question. Suppose that I have 1, 2, 3, 4, okay? And like I said last time, I said we have A, B, C, D, and E, okay? And I have this. Okay, now, if this is my X values and this is my Y values, similar to these tables, okay? Can I change these where I'll put what? I'll put X, let me change the color. Where I'm gonna make this as Y and this as X, okay? Okay, now, looking at XY this way, is this a function? Looking at it from XY, the top is X and the bottom is Y. Is it a function? X is always the domain and
No,
Y
doctor.
is the range. Huh?
It's not a function.
Why? Every element in the domain is mapped to an element in the range. Every element in the domain is mapped to an element in the range. So it's a function this way.
Is it 1-to-1?
Huh?
Is it 1-to-1 function?
No, that one you have to answer because I left that for you to go ahead and answer it. Next class, I'm going to ask you. Otherwise, we will give the answer.
I don't know. Is it?
Huh?
I don't know. Is it 1-to-1, this one?
No. I'm not going to answer it. That's what I said. We have to wait until next class. If you didn't get the answer, I will answer it.
Okay.
Doctor,
Mhm.
I think it is not 1-to-1 because doesn't has an inverse.
Please.
No, 1-to-1.
No, please.
1-to-1.
Okay, don't continue. Okay, now I'm gonna ask you the same question. This is X is the domain and Y is the range. So the input is from X. Okay, if I'm looking at it this way, where the top is X and the bottom is Y, is it a function?
Yes, it is a function.
Excellent. If I looked at it from this way, where this is the Y and this is the X, is it a function?
No, it's not because not every X.
Yes, because not every element in the domain is mapped. Like E here is
Yes.
not mapped to anything. Okay? So things like this, functions like this do not have inverse. Functions like this do not have inverse. Okay? Now, let me give you an example. For a function to have an inverse, it has to be 1-to-1. Right? So let me say that this function is y equal to x squared. 1, 2, -1, okay, and 2. Okay, here I have, let's say, 1 and 4. Okay, so 1 maps to what? 1. -1 maps to what? To 1 also, right? 2 maps to 4, right? And let's just get rid of this 2. Okay? Now, is this function 1-to-1?
Yes, doctor.
No.
No, it's not.
It's not 1-to-1. If it's not 1-to-1, can we find the inverse for this function?
No.
No,
Why?
no, we can't.
Why?
Because
can
there
find-
won't be.
Yes. What is the inverse of 4? Inverse of 4 is
So
2. But what's the inverse of 1? You can't tell. So unless the function is 1-to-1, you cannot find the inverse for every element. If it is 1-to-1, you can find the inverse for every element, right? So the function that we have over here is 1-to-1, so you can find the inverse of every element, right? This is the inverse of the function, of this function. Okay? Now, let's discuss how we can find the inverse. I'm going to give you a simple example. Let us say I'm saying here y equal to 2x plus 3. Okay? This is a function, right? This is a function, right? 2x plus 3. معايا يا شباب؟ Okay, let's go ahead and build this table for it. Small table. Okay, so this is x and this is y. Okay, 1, 2, 3, and 4. Let's just take this. So if x is equal to 1, this is equal to 5, right? x is equal to 2, this is equal to 7, right? X is equal to 3, this is equal to 9. X is equal to 4, this is equal to 11, right? Hi, Shabab.
Yes, doctor.
Okay.
So is this function 1-to-1?
Yeah.
Good.
Yes.
It is 1-to-1. Okay. Now I want the reciprocal of this function. Reciprocal of this function. All I need to do is I change y to x and x to y. So let's change y to x. This will be x, right? And x to y,
Yes.
2y, right? Plus 3, right? Now
Yes.
let me put 2y on this side. If I put 2y on this side, then I will have what? X minus 3 on this side, right? And then I can put y here, and this I will have what? Half x minus 3, right?
Yes.
So that's y half x minus 3. Okay, now verify that this is indeed the inverse of this. Verify that this is the inverse of this. Put 5. If I put 5 over here instead of x5, so 5
It
minus.
should equals to 1.
Okay, good. Okay, now if I put instead of 5, put 7.
It should be 2.
Okay, everybody sees that? Okay, so instead of 7, if I put, oh, let me make it. Instead of 7, I put 9. If I
Should be
put
3.
9 over here, I get 3, right? So this
Yes.
is the inverse. So do you know how to get the inverse of a function? What is the rule?
Yes, doctor.
What is the rule? Change
We should
every,
put rather than x, y.
change every x to y and solve for y. Okay? Got it, everybody?
Yes.
Okay,
Doctor,
so let me just give one more example. Y equal to x squared. Find the inverse.
There is no inverse for it.
Okay, so y equal to x squared. Everybody? So in general, theoretically, if I want to find the inverse, we said what we should do, change the y into x and the x into y, right? Right? And the x into y, right? And then solve for y. So if I solve for y, that means y is equal to square root of what? I mean, if I change, so this is x equal to, y will be equal to square root of x, right? Square root of x is going to be equal to what? Plus or minus something, right? Right?
Yes.
Okay. So the question is this the inverse of this? Is this the inverse of this?
No, a new function.
Okay. If we're using the absolute value and excluding the negative, then is it going to be a function? So let's just put a table here. Let's just exclude the negative value. Okay. So I'm going to put here 1, 2, 3, and 4, right? So this will be 1, 4, 9, and 16, right? So this is x and this is y, right? Now, x and y, that means I'm using this equation. What if I put here y and x, right? Y is equal to square root of x. I'm just taking the positive, okay? So is it a function?
Yes, doctor.
is it the inverse?
Yes.
Yes, it is the inverse, right?
Yes.
Okay. Y equal to cosine x plus 7. Okay, what's the inverse? To find the inverse, we do what? We do x equals to what?
Cosine y.
Cosine y plus 7. And then we solve for what? For y.
For y.
How do we solve for y? We keep this one cosine y on this, and then we go over
X
here.
minus x.
7 minus x. And then we do what? Cosine inverse of cosine y equal to cosine inverse of 7 minus x. Cosine inverse, right? We multiply by cosine inverse. So cosine inverse of cosine will give me y, right? Equal to cosine inverse of 7 minus x, right? So this is the inverse of it. Clear?
Yes, doctor.
Very good. I think we should stop over here and we will continue next class. When is our next class?
On Wednesday, I think.
Wednesday. Okay. If I did not send you any announcement that we're going back to face, that means the room is not ready. Okay? As soon as the
Okay.
room becomes available and ready, we will go there. But otherwise, we were going to lose a lot of time. The boards are all corrupted. We could not erase them. And even the overhead projector, it's blurry. It's not really clear. And if you keep looking at it like this, it's going to destroy your eyes. Your vision is going to be affected. So we cannot do it in the class. And I already told them to do the fixing. Plus also, unfortunately, some people play with the equipment. I mean, like I said in the classroom, I mean, Saudi Arabia is in the forefront of countries now, and it's moving and it's advancing. We shouldn't have people mess up the equipment like what we see there. It's very bad. Anyway, that's it, and inshallah, we'll see you on Wednesday, bi'idhnillah ta'ala.
Thank you.
Doctor,
Yes.
last lecture, I didn't attend the last lecture because I had a chemistry lab at the same time.
Yeah, you told me, Ali.
Yes.
No problem. Don't worry.
Okay. What about the attendance? I mean.
Don't worry about it. Don't worry about it.
Okay.
Right?
And if you have a recording for the last lecture.
Everything we did, we did it today. So you didn't miss anything. I know that we're not really set and ready to go. That's why I will try to be as easy as possible as everybody. I mean, I understand.
Okay, thank you, Doctor.
So don't worry about it, inshallah.
Can we
Thank
leave
you.
now?
Yes, go ahead.
Can we leave?
Oh yeah, please be my guest. Don't tell me
Thank
can
you,
you,
Doctor.
you know why? Don't say can we leave. You know why?
Say may.
Yeah, may I leave? Yes, because you can leave. You're questioning your ability to leave. I mean, you're asking me, can I leave? Don't do that. I mean, you guys have better English than us when we were young. When we were your age, our English was very bad. So that's why I try to correct my students anytime I had a chance. Never say, can I, especially if you go to England. You know, the British are very picky and they're sarcastic. I mean, when you say, can I do this? You say, yes, you can, but you may not. So I mean, don't use can. Anything you can do, don't use can. You say, may I go? May I have this? May I? Okay. كان وكانت كان وكانت يعني ايش يعني I can't do this معناه انا عاجز انه اعمل هذا. When you ask can I do this يعني as if you're not sure if you can or cannot do this. Yes, go ahead. تفضل. يا شباب انتوا لذلك انا بحاول انه يعني نستخدم كل فرصه اذا قدرنا نصلح شيء نصلحه. تفضل.
دكتور ما نكتب الرقم الأكاديمي أو شيء حق الحضور؟
لا الحضور اكتبوا كتبنا 6 اكتبوا 7 هلا اكتبوا 7 و12 7 and that's it for today. بارك الله فيكم. I will see you on Wednesday إن شاء الله. Everybody, before you leave, put number 7 in the chat.